Hi, I'm Neel, and this is my testing recording of my test of the N21-272 caustic substance. I have a large bucket of it right over here, so I'll just pick that up. Oh no, I spilt it! This very caustic substance, it's spreading across the floor. I need to figure out how fast I need to move away from it so that it doesn't burn me up. Thankfully, I have a PhD, so I managed to figure this out. So, I don't know exactly how much of this substance I took, but I know that I took it from this conic container that started out with filled 15 feet high with the substance with a radius of 0.41 feet, and when I left it, it was 10 feet high, filled 10 feet high with the substance with an unknown radius. So, to figure this out, I would have to use similar triangles. I can represent these similar triangles with this. So, 15 and 0.41 with the square 90-degree angle and the A and B angles is similar to 10 and R with the 90-degree angle and the A and B angles. So since these two are similar, 10 out of 15, or 2/3, is equal to R out of 0.41. So if I multiply both sides by 0.41, I get 0.882 out of 3 is equal to R, which is about 0.2733 feet. So now that I have the dimensions of both of these cones, I can find how much I removed by subtracting the smaller cone from the larger cone. So, using the volume of the cone, V equals 1/3 pi R squared H, I can take the volume of the largest cone, 1/3 pi by 0.41 squared by 15, which is 0.8405 pi, and the volume of the smaller cone, 1/3 pi by 0.2733 squared by 10, which is 0.746928 pi out of 3. And I can subtract the volume of the larger cone, the volume of the smaller cone from the volume of the larger cone, which would be about 1.858 feet cubed, which is how much acid I removed. So now I need to figure out how quickly it's spreading using this information. So the container I kept it in was 3 feet high with a radius I did not measure. And so if this was spilled, the acid I know would decrease at the pile of acid would decrease height at -1 feet a second, and the volume would always be this 1.858 feet cubed. So I need to find the radius in order to figure out how fast the radius is increasing and how fast I should be running away from it. So I use the volume formula of a cylinder, V equals pi R squared H. So I divide both sides by pi H. So V out of pi H is R squared. Then find the square root of both sides, and I get V out of the square root of V out of H pi equals R. So R is equal to the square root of 1.858 out of 3 pi, which is about 0.444. So now I need to figure out how fast it's increasing and how fast I should be running away. So I again use the volume formula of a cylinder, V equals pi R squared H, and I find the derivative of it in terms of time, which would be dV out of dt equals 2 pi RH dr over dt plus pi R squared dH over dt. Since the volume is never changing, this dV out of dt would be 0, then equals 2 pi by the radius 0.444 by the height 3 by dr over dt, which is the unknown value we're solving for, plus pi by 0.444 squared, the radius squared, by -1, which is the rate at which the height is changing, -1 feet a second. So if I simplify this, it would be 0 is equal to 2.664 pi dr over dt minus 0.197136 pi. If I add 0.197136 pi to both sides, I get 0.197136 pi equals 2.664 pi dr over dt. And if I divide both sides by 2.664 pi, I get 0.197136 pi out of 2.664 pi. We can cancel the pi's, and we figure out that dr over dt is equal to 0.074 feet a second. So this pool of acid, at the time I spilled it, was increasing radius at 0.074 feet a second. Theoretically, ignoring changes that would happen to this rate as time went on, it would expand by 4.44 feet a minute. That being said, it is soaking my feet, and I'm done with my math, so now my lifeline is over. I'm melting!